dream. It wants to load now. Oh, look at this, dude. Look at this. Now it starts working. YouTube, you need to fix your fucking shit, dude. Like, what the fuck, man? Do I have to keep creating new stream keys for this to work? That's some hot garbage.
It all just keeps collapsing.
Yeah, I don't know why that is. So 1 sec, let me...
Oh, I heard some worrying information about Discord as well.
Yeah, oh yeah, they, what happened? They got bought out, or the CEO is now the CEO of, like, Activision or something?
Both of those things, and then adding in, like, ads and shit like that. People will never use it.
Yeah. All good things must come to an end, I guess. I don't know. Like, eventually, stuff becomes public, and then they, you know, the investors start running the show, and then everything, like, just goes to shit. It's unfortunate. Anyone but who?
Anyone but the current CEO of Discord.
Oh, you don't like the current CEO of Discord? Is he a bad guy?
He brought down Activision.
Oh, is this Bobby? Is that Bobby Kotick?
He was the CFO of Activision, and yeah, every decision he's made since he became CFO
has just been absolute shite. Yeah, they've just been getting railed.
Let's add trannies into our game for no reason. All right. Then.
Oh, I know what you're talking about. Yeah.
What? Nobody bought the game? What a fucking surprise!
Or they start. Yeah, that was the whole. What was it? The Gamergate stuff. 1 second.
No, that was more recently.
Oh, was it? Who were the trannies in the stuff? What was it in?
Was this? Oh shit! What was it? The Dungeons and Dragons game that Activision has.
Baldur's Gate.
Baldur's Gate 3, yeah.
Yeah.
Like
that one had like some weird shit in it.
Yeah, it was the usual sort of. Is your character male, female, or other?
Or is it non-binary? Yeah. I'm non-binary. You know the one with the what is it, the cow? Everyone gets so mad at. Okay, 1 second. We're gonna go live on TikTok. Y'all gotta tell me if the audio is fine on TikTok. I'm seeing like my levels are super high, which I'm cool with, but y'all tell me if it's like too loud or not loud enough. Okay, good. And then YouTube's, yeah, chat's working there for YouTube. Chat's working for Twitch. Dr. Gold looks like Jesus Christ. Don't y'all think the same? Everyone always says I look like Adam Sandler. For whatever reason, I get Adam Sandler a lot.
Well, at least you look like somebody else.
Yeah, right? Yeah.
I look like a shattered mirror.
I look like a shattered mirror. Yeah, people say I look like Adam Sandler. I don't know, man. I kind of see it. Like kind of. I don't know.
What's his real name?
Adam Sandler. That's his real name. Is his real name Adam? Or is he one of these Jewish people that doesn't have his real name as like his real name or something? I'm pretty sure it's Adam Sandler.
To the best of my knowledge, everyone that we know, that's not their real name.
Right, yeah. They all have different safer names or whatever they call it. I don't know. Anyways. Cool. You do look like him. Oh, I appreciate that. Okay, cool. We got 12 on YouTube, which is dope. Oh, and then let me activate TikTok real quick, and then we'll get into questions. So, yes. There we go. I think TikTok's running. 1 sec. It's going to ask me to, like... Oh, no. Okay. We are definitely live. Why is it not loading? Excuse me. The hell? Okay. Or do I need to, like, 1 sec? Sometimes I gotta, like, scan this thing to, like, log in or something. It's really dumb.
There's loads of weird jank on the TikTok thing.
Yeah. You're seeing, like... 1 sec. It's... Chinese make this so complicated. It's like, guys... You know why they have to do it, though? It's because there's so much, like, weird security stuff that, like, goes wrong. I think I seriously, like, 1 sec. Usually I take my profile and there's usually like a scan button or something. Oh, QR code. There we go. And then I need to do this. And then I need to do that. Okay, there we go. And then I need to log in, confirm. Cool. Now I'm logged in. Now it should show my chat. Okay. Whatever. Dr. Will, can you shave one day? No. Never, dude. What? Whatever. I can at least see it here. I don't know why it's not working. I think maybe if I stop this 1 second, let me activate it again. Oh, there we go. All right, cool. We're good. Actual feet. All right, cool. All right, here. We'll kick off the stream, and then I'll help you guys out with some math and science questions. Let's go. Welcome everyone to Office Hours. My name is Dr. Gold, Sex Education. The stream helps you out with math and science homework. All sorts of fun stuff.
Nice.
It is Monday. I think this was my, I want to say my, week 5. This was my 15th lecture I gave at UCLA. I'm starting to get the hang of it. It's, and the students are also starting to warm up a little bit more, which is nice. Because at first, I can understand, you know, a lot of them are freshmen, you know, this is like their first year in college. And they're kind of like, not as, they're kind of shy to speak up. But today, they helped me out because I kept writing like 8 as then 0 as then like 4. It's like having a stroke up there. Like, whenever I do math stuff, I hate doing the numbers. I just want to do variables. Anyways, so yes, they have an exam coming up on Friday, and my office hours was packed after. So I have like actual office hours in an actual office, and they had people like spilling out into the hallway. And I told them, well, you know, I also have this online thing. You're more than welcome to ask me questions here. So yes, if you are in my class and you found me here, congrats. You can also always ask any questions you want. There's a link down there, discord.com, actualdiscord.com/submit. If you go to that website, you can take a screenshot of whatever question you have. Yeah, there we go. We're gonna and you can upload it, and I will see it here, and I will go over it live on a stream, and it's free. It's awesome. Okay, cool. All right, let's see. First question of the day I have is from a Darsh, which has to do with functions and domains. Okay. Cool. Okay. A Darsh question here was, given that g of x has a domain of -4 to 6 and a range of -7 to 18, state the domain and range of g inverse. Ooh. So this is actually pretty cool. Provided the function is like continuous and stuff. You know, no like weird breaks and things. The domain of g of x is the same thing as the range of g inverse of x. Or we write this like g to the -1 of x. This does not mean 1 over g of x. Some people think that. They see the -1, they're like, it's got to be that. And I'm like, no, it's not. So, yeah. And then, by the same token, the range of g of x is equal to the domain of g inverse of x. Yeah. So all you got to do here, Adarsh, you just got to flip them, right? So the domain and range is just going to be this comma this. So it'll be -7 comma 18 and then -4 comma 6. Oh, but these are brackets. So always be careful. It is the opposite. Yeah, it's the flip. Now, there's something... What's up, Cosmic? Test me gold. You can take my tests if you want. After I give the test out to the students, I will give you the test if you want to take it. It's just intro mechanics. It's not crazy. Okay, but Adarsh, you gotta be careful here, because sometimes finding an inverse function means you need to put a restriction on the domain in order for it to become a function. So, what's up, Paper? Good to see you, bro. So let's take something for an example. I'm going to give you a function. Let's say I have y is equal to x minus 4 squared, and let's say, like, I don't know, -2. Okay. So that function would look something like this. So this looks like the parent function, y is equal to x squared, but then there's some modifications to it. So -4 means it's going over to the right 4. So instead of being here, it's going to move over 4 units, right? And then the -2 means it's going to move down 2 units. Okay. So probably looks something like this here. Let's do this. 1, 2, 3, 4. 1, 2, So it's like right here. I can probably find an intercept really quick. Can I? Oh no, because I made this -2. Here, let me make this something nice. Let me make this -4. The reason for that is I want when, for instance, x equals 2. 2 minus 4 is -2. -2 squared is 4. 4 minus 4 is 0. I want this to happen. And then I want this. Okay. Okay. So this is what your original function would look like, Adarsh. Okay. So this would be, for instance, this would be y of x. Okay. And the reason why this is a function is because it passes what's called the vertical line test. Vertical line test means if I draw a vertical line, that line should only hit my function one time, which it does. It only hits it here once, right? Okay. If I were then to figure out the inverse function, let's figure out the inverse function. Y inverse of x is equal to what, right? Do you remember, Adarsh, like the trick? How do I find the inverse of this function? Have you done that before? I wonder if you have.
I know it sounds daft, but do you never just like multiply out the parentheses?
No. Oh, you're talking about like just expanding this?
Yeah.
You could, but then it looks like a messy quadratic. This would be like x squared minus 8x plus 16 minus 4. This is very difficult to graph. I don't know what this looks like. I could factor it, I guess. But this is what's called like vertex form, which is very easy to see because it's very easy to graph because you can see where the vertex is because it's y is equal to, and then it's x minus, let me use some colors, like h squared plus k is kind of how this works. I'm going to use a different color.
Does k always mean constant?
No. C usually means constant. But K here, right? This is referring to the -4. That's where the vertex is located. It's located where at h comma k. So I'll say that's h comma k. And so in this case, right, k is -4, and that's why the vertex is down here at -4 for the y coordinate. And then this x minus h is the x coordinate, which in that case is +4. So it's very easy to see where the vertex of this thing is, and then I know it just does like a u.
Yeah.
Yeah. That's a good question. I mean, that's why we like to keep things in vertex form. So Adarsh, do you know how to calculate an inverse function? So, you know, a regular function takes x values and it spits out y values. This is what like a regular function does. An inverse function takes those same y values and then gives you what the x's would have been. But there's a way to like solve it. Yeah, okay. So, I mean, let's try and solve it, for instance. Okay. If I'm trying to solve for y inverse of x, okay, usually what you do is you write out your original expression, and then you're going to flip the x's and the y's. So I'm going to flip this one with this one. Okay. So instead of writing x here, I'm going to write y. Instead of writing y here, I'm going to write x. So I'm going to say x is equal to y minus 4 squared minus 4. Your new goal is to solve for y. So I can add 4 to both sides. So that gets me x plus 4 is equal to y minus 4 squared. And then I need to take the square root of both sides to get rid of the square. And that's going to give me plus or minus the square root of x plus 4. And then this will be is equal to y minus 4. Yeah, the plus or minus is important here, though. So now I get that y is equal to 4 plus or minus the square root of x plus 4. Okay. So this is pretty cool. So this is also, and then the last step. Yeah, don't make this mistake. You have to replace this y with what you say is like y inverse. What about the -1? Where do you see the -1? Yeah, this part, the -1. Yeah, you're right. Totally right. Ooh, nice. We got a screenshot. Who sent me a screenshot? Alfie. Ooh, I like that one. Yeah, Alfie, I'll do that one next. That's a good one. Okay, so... No, you're right here. Okay, so this is two functions. So, this looks like, to me, y... Let's just say, like, y inverse of x is equal to the square root of x. Which I know looks something like this. This is the square root of x. Alright? So this means it's shifted to the left 4, and then it's also shifted up 4. Okay, so let's... So, for our inverse function, we're going to be shifted to the left 4. So, like, 1, 2, 3, 4. And then we're shifted up 4. So, like, 1, 1, 2, 3, 4. So, like, we're, like, here. Oh, pretty cool. And then, here's the interesting thing. It's plus or minus this. Okay, so you have 4 plus and 4 minus. Ooh, how does that work? Wait. So that means this one... yeah, okay. That means we gotta have this line. This line's definitely happening. But then there's gonna be some other goofy shit going on. Because then I'm gonna flip it the other way and add 4. Right? Because this is like square root of x plus 4. And then it's also like negative square root of x minus 4. Oh, okay. One sec. I think that's what happens. So negative would do, instead of doing this, it would do this. Oh, but then we're minusing 4, so it's coming back up. That's kind of cool, actually. Okay, it ends up looking like this. Okay, so this is your new inverse function here. The cool thing about functions and inverse functions is they are mirror images of each other across the line y equals x. Do you see how this kind of looks like a mirror image of this reflected over this? That's how inverse functions relate to regular functions. And now the other cool thing about this is that this new inverse function that I came up with is no longer a function. Because if I were to do the vertical line test now, it would hit in 2 places. Right? I can pick a bunch of places here, right? And it just ends up hitting in both places. Yeah. So this is not a function. No. So what your teacher can then say is that you have to restrict the domain on this inverse. So basically, I need to like not have the top half of the function and the bottom half. I need to only have one of them. So what we could do is say like, okay, instead of this being my function, I'm going to make it only be y inverse of x is equal to 4 plus the square root of x plus 4. So now this is restricted. Or we've restricted the range is really what we've done. Yeah. So this is called a range restriction. Anyways. Just some more extra info there. Just a little deep dive. But yeah, for your original question, just switch the domain and range. Nice. Good job. Where's my claps?
I still have no idea what's going on. I'm sure I'll catch up eventually, but
Yeah, you hang around enough time, you know, everyone here. Be quiet about laughing stuff. You will pick stuff up. Also, like, feel free to ask questions while I'm doing stuff. Because I guarantee you, if you have a question, someone else watching definitely has the same question. They just don't want to say
it. Just like, well, you know what a slice of Swiss cheese looks like, right?
Yeah, slice. Yeah, I like Swiss.
Now invert that picture. If you can imagine that.
Okay, so instead of having like a bunch of knowledge with holes, you have a little bit of knowledge with great
knowledge and a lot of holes.
It's mainly holes.
you can sort of see where the knowledge is supposed to fit, but.
Oh, I see. Yeah, you're talking about. That's kind of funny. Yeah.
Because remember, I had my. What would you call it?
You had GCSEs, didn't you? Didn't you have GCSEs come up or something?
Yeah, middle school, I guess you'd call it. Although it's slightly higher than that. Anyway, the point is that fucked me up.
Why did middle school fuck you up?
No, I mean, that exam fucked me up. I mean, it really made me feel like I knew nothing.
Oh, no.
So I've put it off for like a year now, so...
I will say that when an exam like, well, so it's different because you weren't like this was you self-studying for something, right?
It was 1 day a week in class.
Oh, it was in class. Okay, yeah. So I say like, if a student like takes a test and does really poorly on it, it's not necessarily all the student's fault. It means the teacher sucked too. Because I had this on my midterm. I wrote like what I thought was like kind of a challenging question for one of the test questions, but only 18% of the class got it right. And so I just tossed it because in my mind, if only 18% of the class got it right, that means I didn't teach it well enough. And so it's not the students' fault that, I mean, at some point, if they're not making the effort, not doing stuff, then yeah, that's their fault. But if someone does poorly on an exam and they really tried, then that's the fault of whoever designed the exam or taught for the exam. I feel like it's their fault. Yeah. So whoever wrote your exam sucks.
I certainly think that precursor knowledge is a big factor, though.
100%. I agree with that. Yeah.
I mean, I hadn't studied maths in like 20 years by that point. Or more, right. Potentially.
So it's hard for it to all like come back.
So I mean, I got a C, but
okay.
it wasn't close to where I want it to be. I was going to say needed to be, but then.
But it's better than failing. You didn't fail, right?
As long as you get a GCSE, you can take your A-levels.
Oh, nice. Well then, yeah. So what I would do is, right, you know, do you get that exam back? Do you get to see what you did wrong?
No.
Oh.
It would be impractical.
But I mean, you could take a practice exam, self-grade yourself, and see what you get right and see what you don't get right. And then, I mean, and that's the whole point of what I do on the stream, is if you come to me and be like, hey, I got this question wrong, I can pretty quickly figure out what precursor knowledge you were lacking that prevented you from doing it. And then we make sure you know the precursor knowledge. Yeah.
I just remember there was one of those daft questions where it's like, if a pipe is emitting so many liters per second, and the shape of the tank is an inverted cone. Yeah, that is right. An inverted cone. How long does it take to fill up the tank?
Oh, I love these. This is something like this, right?
Yeah.
And then there's like water spewing out of it or something, or there's like water going in. And they're asking like, this is actually a calculus question. There's a calculus question in this, which is you can figure out the rate at which the height of the water is going up based on the rate at which the water is going into the cone. I don't think you were. But you weren't asked that.
Calculus does not exist at that level.
Yeah, it doesn't. Yeah. Find me this problem if you know where it is. Like, I'd like to see like the one that you took because I'm curious to see what they asked.
Funnily enough, I'm pretty sure every exam has to be put online.
Did you mean funnily enough?
Funnily enough.
Anyways, okay. That was my attempt at a poor joke.
I've got a worse one for you.
Yeah.
Well, it's Americans do use metric every day.
What do we use metric every day for?
Well, in school, everyone uses a 9mm.
You done messed up, Ron!
It's fucking hilarious, but terrible.
Sorry.
No, I love that. Everyone uses a 9mm. Cosmic says, not gonna lie, I stopped showing up to one of my professor's classes due to me showing up to her office hours and basically not helping me. I basically self-teach the content. Yeah, no, exactly. Yeah. And, you know, I tell students that I work with as well that if you're not learning anything from the class and there isn't like a required reason to be there, don't show up. You don't need to. But use that time that you would be in class to at least like go watch some YouTube videos or something else. Like, you know, don't be like, oh, now I'm just free to just, you know, jack around and do whatever I want. You should still use that time to study, but I totally agree. It's especially if you get into some like higher level uni courses and you're with professors who are very much not native English speakers, it can be really difficult to understand what the hell they're saying. And at that point, yeah, just peace. E. Raven says it took them 10 minutes to get the 9mm joke. It took me 20 minutes to say it. St. Ross says, I learn way better reading the material myself, too, if the textbook is good. 100%. Yeah, certain textbooks are great. Other ones, like, fucking blow. But I've worked with a lot of different subjects and textbooks, so if you have a specific class and you want a recommendation, I probably have a PDF of it. So I can probably just DM it to you. So just, say hi. Anyways,
just quickly, for Cosmic's benefit.
Yes,
before you carry on.
You're good.
For Cosmic's benefit, past tense of teach is taught. It's important to know that it's a basic linguistical rule.
It is. It's important. Good. Discipline. Russian accent. Yeah. And Russian teachers are fucking brutal. I mean, they grew up in like yeah. They are a brutal culture. Like they do not live in very like comfortable times. So teach the Jacobian. All right. Well, let's see. Well, the first question here is that says, given that y is equal to arc sine of cosine of theta, where theta is between 0 and pi, show that dy d theta is equal to k, where the value of k is to be determined. Okay, cool, fine. So, if we have, for instance, I'm just going to draw this graphically what this is. Okay, so they said that theta is restricted from 0 to pi. Okay, so that means that my angle here has to be somewhere in these top two quadrants. Okay, and arc sine, cosine of theta, interesting. So I'm gonna do a little identity here, which is that the cosine of theta, I believe, is equal to the sine of pi minus theta. Correct me if I'm wrong on that. I'm pretty sure I'm right. Yeah, please press the like button. Yeah, we love that like button, dude. Hit it. Okay. Where's my identities? Where doth? Oh, it's sine pi over 2. That's what it is.
Think of it as payment.
It is payment. It's payment that's free. They don't have to do anything. Here, this is what I want. This is the identity I want. Yes. Oh, I think I was right as well. No, sine of pi. Okay, so this is wrong. One sec. This is the identity I wanted. My bad. I make mistakes sometimes. Not very often, but I do. Pi over 2. Thank you, Jeff. Jeff, always my guardian angel, dude. Jeff, you get a save. Thank you, Jeff. Okay. So, I'm gonna rewrite this as y is equal to the arc sine of the sine of pi over 2 minus theta. Okay. Now, arc sine of sine cancels each other out. So we end up getting that y is just equal to pi over 2 minus theta. Cool. And this is for theta was in between. That's very interesting because arc sine is restricted to these quadrants in terms of output. So that's why we are going to get negative angles. Because when I look at this, right, this is pi over 2 minus 0 to pi over 2 minus pi. So that restricts me from pi over 2 to negative pi over 2. Which, yeah, great. That's what these two quadrants are. So that makes sense. Okay, cool. Show that dy d theta is equal to k. Oh, okay. Well, if y is this. Ooh, Nini says, on the last problem today in class, I was confused how we got the after equations after we got the x and y components. Okay, Nini, I think you're talking about, was that the thing like exploding in the air and stuff? I'll pull that up. I'll pull that question up next. Let me finish these ones real quick. Welcome to the stream, by the way. Yeah, this is where we help people out with math, science. So we have like kind of a queue. Like people just submit questions. There's a website down there that people like will send like a screenshot. I know what you're talking about. But if it's something that I don't know, or if it's like a homework question specifically somewhere back, it's really super simple. Just send a screenshot. But I will get to it. Let me blow through this one real quick. Okay, pi over 2 minus theta. So dy d theta, this is going to be 0 because it's a constant, doesn't have theta. And this equals negative 1. Cool. K equals negative 1. These are just ugly. Find the value of the gradient of the curve. So gradient, I believe, is equal to is this grad? Which I believe is just like in one dimension is just dy dx. So dy dx of, because this is a one-dimensional curve, x to the third arctan of 4x. This is going to be a product rule. So derivative of the first, 3x squared, times the second, plus the derivative of the second. I believe the derivative of arctangent is 1 over 1 plus x squared. One sec. Oh, thanks. Yeah, okay. One sec. Arctan derivative. It is 1 plus 1. Okay, cool. Got it. Yeah, 4x. Thank you. Thank you. Yeah, this is the other important thing. Good one to know. Oh, I lost my thing. Oh, nice. Oh, you sent me the screenshot. Love that. That is perfect. That is a great example of how you get help here. Okay, good. Sorry, this is 4x. And then this is the derivative of this, which in this case, this right here is like u. So this would be equal to 1 plus 1 plus whatever this is squared. So that's going to be 4x squared. But now you have to do a chain rule, because now I need the derivative of what was inside. So that's going to be derivative of 4x, which is just 4. And then times the original, which is x cubed. And then they want us to do this when x is equal to pi over 2. Okay, fine. So that's 3 pi over 2 squared times the arctan of, what is that, 2 pi? Oh, that's just weird. Okay. Plus 1 over 1 plus 16 pi squared times 4 times, what is that? Pi cubed over 8? Oh, this is just ugly. Like, what? No. It hurts my head. Anyways, but that's how you do it. Like, congrats. Yeah. Nice. Okay. Alfie, let me do one more question for someone who's asking a physics thing, and then I will finish this last one for the normal to the curve. But hopefully, yeah, it's not too bad, this stuff. Okay, let's see. How did we get this? Cool. All right, yeah. I like that you sent this. This is perfect, because now I can just like, well, not this. Excuse me. Copy image. There we go. Okay. Man, college is so cool. They got like iPads and shit they take notes on. Like, look at this. Me when I see numbers greater than 4. Yeah. Okay. How did we get this? Okay, so you're asking about these parts. This stuff. So this is like momentum before, and this is momentum afterwards, and you're asking about all the momentum afterwards, I guess. Totally cool. Yeah, all right, let me do it. I'm going to start this question from scratch, just to kind of demonstrate to everyone else, and then I think things will start to make a little bit more sense. Okay. So, oh, Swa did post stuff. Did I help Swa out already? Swa, I will help you out. I like the E&M question. I'll do that next. Okay. This is Newton's laws. It's actually conservation of momentum, Cosmic. You think I've done this one before? I don't think I have, because literally I gave this question today as a in-class clicker question quiz for my students. Yeah. Maybe I have. Oh, split into 3 pieces. Yeah. I mean, this is a common thing in momentum, is to have things split. Okay. So what we have is we have a couple situations. So a firecracker is launched with an initial velocity. It goes all the way up into the air, and then it explodes. And then once it explodes, it breaks up into 3 pieces, and like a bunch of other stuff happens. So I'm gonna put a bunch of different like situations. Okay. So we have like on the ground. We have in air. So we're gonna say at the peak, because it says the firecracker explodes at its highest point. So I'm going to say at peak. Right before the explosion, Exactly. Yeah, Cosmic, you're getting into it. Yeah. And then we have right after the explosion. Yeah, because there's conservations of things. So let's see. So I like to draw like what's happening. So when it's on the ground, it's launched with an initial velocity of 70 meters per second at an angle of 73 degrees. So let's kind of draw that out. Also, this hip-hop radio is a little loud. I'm trying to stand a little bit. Thank you. Okay. So here we have it's being launched at 70 meters per second. And it's being at an angle of 73 degrees. Cool. And what we know is eventually this thing breaks up into 3 equal pieces at the end. So before it breaks up, it's going to be in 3 pieces together. So I'm going to just draw that like this. These are like the 3 pieces. Okay. Now, it reaches the very, very, very top that it can. And then it's going to explode. So when it's at its peak, right before exploding, we're going to have these same 3 masses chilling here. Okay. And we'll talk about them. And then right after they explode, okay, different things are happening to different chunks here. Okay. So what they say is one of the pieces continues at the same horizontal speed. Okay. So one of these chunks here, let's call this like chunk, whatever, this chunk. Call this like chunky one. It's going to continue at the same speed that it did before. So I'm going to call this like, let's call these different, I want to call these different situations. Yeah, okay. I'm going to label the situations 1, 2, 3. So watch. I'm going to say this is situation 1. This is situation 2. Situation 3. And then I'm going to label the different chunks as A, B, and C. Okay? So I'm going to call, and let's use different colors for this. Yeah, I'm going to call this like A. This is chunk B. And then this is chunk C. Okay. So, together, right, we still have the same ABC. Okay. And all of these things, right, are moving together at some velocities. So, they're going to be moving at what we're going to call, like, Vx2. So, the 2 here signifies that it's the second, like, time point at what's happening. So, they're going to have some velocity in the x direction, and then they're also going to have some velocity in the y direction. We're going to get into, like, why this is 0 later, but okay. Right after the explosion, one of the chunks, let's call that chunk A, is going to have the same velocity that it did when it right before it exploded in the horizontal direction. So we will say this is VAX, and then it's like 3. And then we also say that that one piece that's continuing at the same velocity this way is moving horizontally upwards with a velocity of 10. So it's moving to the right, and it's also moving up at 10 meters per second. That's one of the chunks. The second piece moves vertically down. So let's take chunk B, for example. Chunk B is going to move down at 10. But is going to move backwards with a velocity of 30, okay? So B is moving down, but it's also moving backwards at 30. Okay. Cool. And then there's a third piece that we don't know what it's doing at all. So here's the third piece, and its velocity is kind of like a question. We don't really know what's going on. So this and this is like question. We don't know what's happening. Okay. So what I'm gonna do is, because between right before it explodes and right after it explodes, there is no external forces causing the explosion. We say like it just happens like, I don't know, spontaneously. We know that the momentum here has to be equal to the momentum here. Okay? So what we're going to do is we're going to write out what the momentums are in both situations. So this is momentum 2, and then this is momentum 3. Note that these momentums don't equal this one, because as the thing starts in the ground and then goes up into the air, gravity is always fighting it, and that's an external force. So that's why momentum is not conserved from it being on the ground to it being at the peak. But from it being at the peak before it explodes and right after it explodes, the momentum is conserved. Okay. So we're going to write out momentums in the x direction and in the y direction. Okay? For each of these. Because we need the directions to match up. So, for situation 2, before they've exploded, okay, remember that momentum is equal to mass times velocity. So we're going to do that for each of these. So each of these have a mass of m. So I'm going to be like, okay, cool. That's just m times vx2 plus m times vx2 plus m times vx2, which is going to equal to 3m vx2. Okay? Because in the x direction, we take the mass times the velocity in the x direction. And then for the y direction, it's going to be m vy2 plus m vy2 plus m vy2. And this will also equal to 3m vy2. Does that make sense so far? Figuring out all the momentums of each individual thing. We're just doing the mass and velocity of each one. Technically, you could say this was like MA, MB, MC. Good, okay, MA, MB, MC, yeah. Now, and because they're all M's, it just adds up to 3M. Now, there's a little bit of a trick here. So they say the firecracker explodes at its highest point. And what we should know about highest point is that Vy, velocity in the y direction, is 0. So this velocity is 0. Okay? So that goes away. This is 0. Okay. All right. Now let's look at situation 3 after things have exploded. Okay? So in the x direction, let's look at mass A, right? So we're going to have mass A times whatever its velocity is, which I'm going to say is like VA x 3. So this means velocity of block A in the x direction at time point 3. This one is going to be minus m times 30, because it would be plus m times negative 30. The velocity here is negative. And then it's going to be, and then here, maybe let me put the plus so that doesn't confuse you. Because you are just adding a bunch of momentums, but the velocity here is negative. And then here, this is going to be the mass of the blue one times some we don't know. So I'm just going to say this is like let's just call this like VBX. Good, so we're going through the x-axis, exactly. I'm doing the x velocity of this one, the x velocity of this one, x velocity of this one. In the y direction, that's going to be m. So for this one, y is going up by positive 10. So that's going to be positive 10. And then it's plus m. And then this one is going down by 10. So it's negative 10. Okay? And then again, we don't know what this third piece is doing. That's like a question. So this is going to be plus m And then this is VBY3. Do you teach privately? I do. I definitely do. Yeah. This is free. This is publicly free. Privately is expensive because my rent is not cheap. Los Angeles is a brutal place to try and make money. Anyways, so here's some cool things. All right, so now what we're gonna do is we're gonna say momentum in 2 needs to equal momentum in situation 3 for each individual direction. Okay. So in the X direction, how can you contact for private? I have a website somewhere. One sec. Let me get it to you. One second. Actual.education. And then... Oh, private tutoring. There you go. Here, I'll give you the link. Where's my YouTube chat? There you go. Okay, so in the X direction, our total momentum was 3m vx2. And then in the X direction for momentum 3, so that's going to be m. Well, so let me think. Yes, it is going to be this. All that. Well, here, I want to copy it, but not take all of it. One sec. And then here, I'm going to try and like simplify some things. Let's make some things nice. So here's a little bit of key information, Nini, that came up. So do you notice how they said that one piece, so the first piece, piece A we're looking at, continues at the same horizontal speed that it was right before it exploded? That means that the velocity of this piece, the VAX3, this velocity is the same as VX2. So I can actually replace this with this velocity. It'll make things slightly easier. Even says, hey, I'm new here. It seems like you're doing some physics. Amazing. Honestly, I've never seen live physics streams before. This quality. That's dope, dude. Yeah. Yeah, we're doing some physics. If you have questions about physics stuff, feel free to ask. We have a whole, like, there's a website there you can just submit screenshots to, and I'll do them. This is actually for a UCLA class I'm teaching. This is one of the questions I did in lecture today. Yeah, we don't know. Hey, what's up, Sensation? What's your question?
Why is EB so popular? I've just noticed loads of people have
the Pokemon
pictures of it. Yeah, the EB.
Wait, EB or EV?
Yes.
Like, wait, this Pokemon?
That one, yeah.
People like
EV.
this Pokemon?
Right, okay.
EV. Well, this is old school, bro. I mean, this is back when I was like in middle school. Today is Canada's election day. Wow.
Just as the person said something, I noticed the image and I was like, I'm seeing EV, sorry, quite a lot.
Yeah, well, their name is Eve Neon, so Eve Neon. So maybe it's like evening, but Eve Neon. Yeah. Eve Neon, explain your name to us. Sensation would love it. Yeah, I decided this is like, so they say that I decided this screen name 6 years ago and had this PFP and nickname since then. Dubs, dude. Yeah, picking your first screen name. Tried to be original, dude. Do you want to know what my first screen name was ever on the internet? It was Cool Skater 215. I was like, because I like to skateboard and I think I'm cool, so I was like, I'm a Cool Skater 215. Yeah. So
see, I was just sad that it was my full name for a very, very, very long time.
Oh no, dude. These kids these days will use anything but their real name online. It's just like, nope, won't do it.
I don't have an identity until I have a handle.
I know. Anyways, Nini was asking, even if we don't know what VX2 is, totally okay. So in physics, a lot of times you won't know what variables are until kind of the end. So you have to kind of just like trust. I know it's scary sometimes, but you have to be like, I'm just going to leave it like this. And then hopefully later down the line, it'll either cancel or I'll figure out where it's supposed to come from. Yeah. Cool physics dude these days. That's another good. That's one I could use. Cool physics dude. Okay, so I'm going to leave this as Vx2. This is now going to be, so m times negative 30, that's just going to be the same thing as negative 30m. I'm just right just to make things look nicer. Minus 30m. And then I'm gonna put the m over here as well, just because it'll look nicer. Okay, so now let's look at the y direction. So let's remember in the y direction that because this explosion happens at the top of its trajectory, that all the velocity in the y direction is 0. So all the momentum in the y direction has to also be 0. Okay. And then this is equal to, so let's copy this down. So we had m times positive 10 plus m times negative 10. Well, these things just go away. Like, goodbye. We don't need these. Right? Because this is the same thing as 10m minus 10m, which is just 0. And then we say this is plus m times vby3. Okay. Well, this is gone. So I just have 0 is equal to, what's up, equity? Is equal to m vby3. So in that case, the velocity of this unknown thing, right? Remember, this is, or sorry, it wasn't vb, sorry, it was vc. I fucked up the whole time, sorry. This is c, sorry. Mass c is the one we don't know, right? Sorry, let me change that. Change it real quick. I make mistakes sometimes. Also, if things don't look like right, feel free to like correct me. I make mistakes. Okay.
The God paradox.
Yeah, the God paradox, yeah. So this is the missing thing we're looking at. I did at least color code it correctly, right? The blue stuff is still the blue stuff. Momentum, it is momentum. Yes, momentum. Big dubs on momentum today. Okay, so this says that the velocity in the y component of my third piece after the explosion is going to have to be 0. Okay, so now I know, cool, this is equal to 0 in the left-right direction. Okay, so all that's left to do is to try to figure out, or sorry, not in the left-right, sorry, in the up-down direction. The y component's up-down. This is 0. So the third piece doesn't go up or down because the momentum from this one going up canceled the momentum from this one. What causes the 10 minus 10? All right, let's do it. Yeah, sorry. Okay. People on TikTok, what's up? Okay. So for the momentum here, right after things have exploded, right? If we looked at the y component momentums, remember that block A, the first one, went up at 10. So its momentum was m times positive 10. Block B went backwards at 30, but went down at 10. So in terms of its y component, its momentum was m times negative 10. Okay? So m times 10 is the same thing as 10m. You can just rearrange the orders of numbers. So this is the same thing as 10m. And then plus m times negative 10 is the same thing as saying plus negative 10m. And 10m plus negative 10m is 0. Does that make sense? I can go back through and show it. I know it's sometimes I hate when I skip things. Okay. Nice. Okay. So if this is 0, and then all that was left, right, was the momentum in the y direction for this third piece, this c. Well, this is 0. The total momentum needs to add up to 0. So that means this must also be 0. So that tells me that this third piece has no velocity in the y direction. Okay. So all that's left is to solve for the velocity in the x direction. Now, if we take this equation here and let's rearrange it. So I have an mvx2 here and a 3mvx2 over here. So I can move that thing over. So that's going to be 2m vx2s. And then we're going to say plus 30m is equal to my velocity of my C thing after the explosion times m. So all I did is I took my momentum in the x direction for before the explosion and after the explosion. I set them equal to each other, and then I rearranged to solve for this thing, because this is what we want. What you should notice here is that there's an m in everything, so that's going to go away. That goes away, that goes away, that goes away. And now we're left with 2vx2 plus 30 equals the thing I'm looking for, which is vc in the x direction for situation 3. So I need to know this. Once I know this, then I know this. And we'd be good, okay? How am I going to get that? Okay, now I need to look at what's happening between situation 1 and situation 2. Situation 1 was when it was on the ground, before it had been launched. Situation 2 was at the peak. So what I know is if I have something going at a velocity that's diagonal, I instantly want to convert that into x and y components. Because everything we've been dealing with in terms of momentums and whatnot is always just x, just y. It's not in any sort of diagonal direction. One second, let me fix this. Okay, cool. So what we're going to do is we're going to break this up into... let me use I can use a fancy thing. Let's use a fancy. Liberals better not win again. Oh, in Canada? Yeah, I thought the Liberals were going to lose, and then apparently Trumpy started, like, saying too many things, and now, like, I don't know. Now they're like, maybe we want the Liberals, because otherwise y'all can become our 51st state guys. Okay. This is going to become... This is the y component, right? So this is going to be 70... sine of 73 degrees. And then this is the x component, which is going to be 70 cosine of 73 degrees. Right? And this is like, I would say this is V1 x. And then this is V1 y. Okay. Now, what I know, for something that's in the air and being thrown at an angle, while it's in the air, the x velocity does not change. Doesn't change. The y velocity does, right? It's originally going up pretty fast, and then the y velocity like kind of stops here. And then it starts going negative again. But throughout this whole time, the rate at which it's traveling in this direction stays constant, which is this. So V1x, which is 70 cosine of 73, which, one second, let's pull out our calculator. So 70 cosine of 73 is equal to 20.46. That's the same velocity in the x direction at situation 2 right before it explodes. So this is the same thing as V2x or here Vx2, whatever. Does that make sense, Nini? How this velocity is equal to the same thing as this velocity? That's a very important concept. Sometimes doesn't click all the time. Yes, okay. Alright, so now you're done. Because whatever this is, it's going to come down into here. And so now you have 2 times 20.46 plus 30. And I'm going to just approximate this as 20. So 2 times 20 is 40. 40 plus 30 is 70. And so 70 is the velocity of the C block in the x direction at time point 3. So you can just say 70 meters per second is the velocity of the third block. And then you're done. And that's how it works. Does that make sense, Nini? And then what?
Have you never seen that stupid film?
No.
Dude, Where's My Car?
Oh, dudes are required. Oh, she said scroll down real quick. Okay, good. Yeah. Actually, so Nini, if you want, I can save this whole thing as a PDF if you want it. Here, let me save it as a PDF for you.
And then you can go here.
Yeah.
If it comes on.
Yeah, it'll be on the Discord too. But
there we go.
They may not have Discord. Some of these students don't have Discord. I'll post it in Campus Wire. What was this? This was question 5. Question 5. And then what was today's date? The 28th, I think. Oh, download current page. Well, I'll just download it as a JPEG. Yeah, so then what I'll do for you, watch, I'll put it on Campus Wire. So, here. I'll say, question 5 in lecture, are some, here, an additional information that was done during a live stream. We'll post a recording to it soon. Okay. So, I think I could just post this in here. Or wait, maybe I have to actually upload it. Let me upload it 1 second. Oh.
It's an interesting point that ADIC makes.
What was it? What was the point? What was the question?
ADIC says that's a very important concept in game development to make physics, animation, etc.
Totally is.
Yeah, because even outside of game development, any object that you make on a two-dimensional plane, any two-dimensional object that you make, you still have to program in the physics. You have to sit there and say, right, G exists as a function of this object.
Momentum does this, and they're all relative to each other.
Yeah, and then you have to set its x and y coordinates and have it follow physical rules in order to not look really odd.
And like strange, yeah. Usuma says, what is he saying here, dude? Can you do a Laplace transform with a periodic signal? I mean, I can.
Osama.
Usama. Is that like Osama?
Osama. No, King.
Oh, okay. King Hassini.
Osama.
Sorry. Yeah, if you have an example question. So again, yeah, for those that are watching us on, we got 29 on YouTube. Like, what's up, boys? If you just go to actualdiscord.com/submit, there's a website here that you can just put in whatever name you want. I mean, try to make it your name on YouTube so I know who I'm talking to. And then you can just upload a screenshot of a sample question you have, and you hit upload here, and then I'll get it. And then we'll do it on the stream. So.
Torikaku, Osama Janayo omae.
Bum bum bum.
He probably doesn't listen to what I said. Never mind.
No, I don't spend it. Maybe someone on the stream does. Okay. All right. Let's see. Let me see. Is Swa still here? Swa still around?
Was Swas ever here?
I thought you said Swa was typing something earlier.
He posted something in help screenshots and then tried to do something in help screenshots. It won't tell me what it is in the admin. It just says he's deleted a message, and it's like, okay, cool. Did he try and type something or not?
No. Well, yeah. Sometimes, yeah. They don't know that you can. Oh, you got the answer.
No.
Oh, all right. He says thank you. What was the answer, by the way? It says in the given output, the input is applied across terminals A and C, while the output is measured across B and D. What is the nature of the output? Interesting. So these are called diodes, which means they only allow positive current to flow, right? So I believe these are rectifiers, right? So that if, for instance, if you have a signal that looks like this, I believe putting a diode across it like chops it so that you only see like this. Is that right?
I think so.
Going across here. And then I think across here, you're going to get the negatives. So
if you showed me that on a board, I could probably figure it out, but
Is it the same as the input? I don't know. I feel like you'd get the peaks here, and then you'd get the valleys here. This is like some double E shit. That's with two diodes. Or sorry. The signals applied across terminals A and C. Does the signal have like a polarity? No. I'm just curious. What do you mean it's applied at A and C? I always like to learn. You guys teach me sometimes, honestly. I have a decent knowledge of like electrical engineering, but
well, input to A and input to D, and then and an output from the other two. And so you've got the two rectifiers facing each other at one output and facing away from each other at the other output.
So shouldn't you get the same as the input, right? You know what I could do?
I should know this. I don't.
Let's just ask ChatGPT.
Yeah, solve this, right?
Well, I just want to learn something today. You know, I like learning. And then, yeah, I see someone, Anton, you submitted a physics question. I saw it. Here, I'm going to solve this. Solve this. Go.
I'm gonna say please.
Okay. It's a bridge rectifier. In the positive half cycle of the AC, the two diodes pass the positive. In the negative, the two, right, provide the voltage. As a result, both halves of the AC unit are converted into positive voltage. Oh, so it's a full wave rectifier. Oh. Yeah, silly me.
Make it do a diagram.
Well, I could make it do a diagram, but yeah, could you send the solution sheet? I'm actually curious. So I think what he's saying, so AC, right? There's gonna be an oscillatory signal, right? And so this will only allow the positive part to flow through, and that will come off as a positive signal. If this is negative, then it will allow the negative side to go through, but I think that also comes off as positive. So that's why it's a full wave rectifier. I think what this happens is, if this is like your input signal, you end up just getting like, you just end up getting this. You just get a bunch of these. Oh, Swall's gonna post it. I want to see. I'm curious.
Does that count as pulses?
Yeah, they're pulses. Yeah, for sure.
Hmm. Let's see who's around.
Yeah. No, I think Equity's around.
You?
You got questions too. I want to do your sensation. I do. Eventually, I will get to this one. This is actually a very interesting question, because I'm not sure that like, it's weird with like conservation of momentum, because technically you have gravity, which is pushing down. So gravity is doing stuff. All right, one sec. This is what they said on paper. One sec. I want to see. Okay. Use the concept of a full wave rectifier. Find the nature of the output. Applying an input across A and C. What is this? What does FB mean? Full band? Oh, forward biased. Sorry, they're talking about biased. Forward biased. Forward biased. This. Forward biased. Okay. For the positive half cycle, we obtain an output as current flows from A to B, and then from B to D, and then D to C. Oh, okay. Yeah, the potential divider. Yeah, you mean like a voltage divider? Yeah, totally can. That's a fun one as well. Can you give me a screenshot of like an example question? For me to like just to explain it is, you know, it helps if I know like what level of math you need to know. Oh, that's cool. So yes, so when you have a positive thing for A to C, forward biased means it allows current to run through it that way. So that's why, for instance, the positive cycle on A to C will come through on B to D. But if you reverse the input, so reversing it is the negative cycle. Now it doesn't go through here, and it goes through here, and it comes back. Oh, okay. Okay, cool. That's pretty cool. SAT, I'm doing my Irish dude, it's so funny because like we do not have any sort of circuits on the SAT in the US. Does not exist. Here, let me Let me do this one real quick. This is a decently manageable one. Rather than me like learning double E stuff like real quick. And then I will do that one and then I'll do I can do more circuits. Okay. So let's see sensation. It says the nth term of a
I do the answers as well. Sorry.
Oh yeah. I see the answers as well. Says the nth term of a sequence is given by this. Work out the difference between two consecutive terms. Okay. Do you know what that means, like consecutive terms?
One after the other.
Good, one after the other. No, exactly. No, yeah, consecutive means like one after the other, right? So you could think of like a term, for instance, like n equals 1. And then the next term would be n equals what?
What, given that function?
No. Just for instance, if n equals 1 is the first term, the next consecutive term would be n equals 2, right?
Yeah.
So good. So all you have to do is just plug in here what that is, right? So here you have 2 times all over the place. 2 times 1, right? Plus 9. And then here you have 2 times 2 plus 9. And so you can just figure out what this is, right? This is 11. And then this is 13. So the difference between them is
2.
Yeah. You can also see that just without even doing this. This is like the, I don't know, the brute force way. Just looking at what the sequences are. So as n goes up by 1, this whole part goes up by 2. And then this is constant. This doesn't change between the terms. So what they call like the common difference between the terms is 2 because it's this thing. Yeah. If this was like a 5, then the difference would be 5. This isn't the 6, whatever. Whatever's in front of this n, that's the difference between consecutive terms. Okay. So then they say 2n plus 9 is less than 99. Whenever I see this stuff, you just treat it as regular algebra. Pretend it's an equal sign. And as long as you don't divide by -1, you're okay. So if this was regular algebra, how would you solve this?
Minus 9.
Yeah, just minus 9. Minus 9.
Divide by 2.
Divide by 2. So then you get n is equal to 45, but... Whoa. It wasn't equals. It was less than. So you just get that. N is less than 45. Yeah, cool. Write down the number of terms in this sequence that are less than 99. Ooh. Oh, that's tricky. Okay. Well, what this told me, right? Okay, so let's think about... Wait, and does n have to start at 0? Like, can I have the -1th term?
I would imagine not.
Yeah, right? Lax says he thinks it's 45. I think the answer is technically 44. So, we'll watch what happens. Okay. So, we know, right? The n equals 1 term was equal to just 11, right? And then n equals 2 was equal to 13, and so forth and so forth. And what we did, the reason why they made this do this, 2n plus 9 is less than 99, is they wanted to see what value of n here gets me this whole term to be less than 99. And we solved that, and that was 45. Because watch what happens. If I put 45 in for n, right? This is funny. Like, the first two things I think were softballs, but then, like, this is, like, kind of tricky. Okay. This gets me 90 plus 9, which is 99, right? So, you're not allowed to use...
Oh, no.
You're not allowed to use the n equals 45 term, because it's equal to 99. And that's why also here, do you see how I said n was less than 45? So, you're allowed to go all the way up to n is equal to 44, which would end up equaling, I think that's 97, right? N equals 45, not allowed. Not allowed to do this one. Can't do it. Okay, so now you need to know how many terms are there between n equals 1 and n equals 44. And the answer is 44. If you ever get confused about this, I always think, like, pick, like, 2 closer numbers. Like, how many numbers are in between, like, n equals 1 and n equals 3? I'm like, okay, cool. It's 3 minus 1 plus 1, right? 3 minus 1, which is 2, and then you add 1 because you're counting the endpoint number as well. So in this case, it's 44 minus 1 plus 1, which gets you 44 terms. It's the fence post problem. Yeah. So if they allowed n equals 0, technically it would be 45, but I guess it's kind of implied here that you can't have a 0. This is up to debate, right? I don't like this because in computer science, we index things at 0, and like there is a 0th term. But I think in math, they start everything at the first term. Correct me if I'm wrong. I think all sequences have to start at the nth, like the first term.
Isn't that a thing? It's like something can't be less than 1.
Well, it's like 0 isn't like a real number. Like natural numbers, I think, don't include 0. Something like that. Like 0 is like a concept. It's nothing.
Whoa.
Whoa. 0 has like weird pronouns that we don't know about. Anyways. Equity, what's up? Do you have a question, Equity? Can I go through yours? Otherwise, let me go through Anton's real quick, and then I can also do the circuit thing if you're still here. But let me look at this question. One sec. And then we'll go through Shantrix and all yours as well. Okay. Let's pull it up. There it is. Okay. So, they say a small block of mass m, 0.5 kilograms, is released from the top of a frictionless, curve-shaped wedge of mass m2 is equal to 3 kilograms, and which sits on the surface. When the block leaves the wedge, its velocity is measured to be 4 meters per second to the right, as shown. What is the velocity of the wedge after the block? So this is cool. So they're saying that, like, you have this, right? Here, let me, like, draw some pictures. It's kind of cool. This is a mindfuck of a question. I will probably get this one wrong, honestly. Just because certain physics things, they just want to confuse you with. Do I have, like, a triangle thing? Oh, I don't really. Okay, whatever. So what they're saying is that, like, as can I grab? No, what? One sec. Let me make this solid. Then let me grab it. Okay. Okay. They're saying as this block moves down, this thing gets pushed over to the left. They kind of like, they compete with each other. Like this goes this way, and then this thing goes this way. Now, where I have to be careful here. I'm tempted to say that M1. I'm tempted to say that here, momentum is 0, right? But then here, momentum must also be equal to 0. So I'm tempted to say that M1 VF has to be equal to M2 V2. Like equal in opposite directions. But I'm not sure. We need more men, damn it. Where's that from, dude?
I've no idea. I used to say it all the time back in the day.
Okay. I think I'm allowed to use this because there are no external forces in the horizontal direction. There are forces in the vertical direction. There's gravity. Gravity is pulling this bitch down. And so there is definitely no conservation in the y direction, I don't think. So I think you're allowed to just say this. I think, you know, momentum in the x direction is 0 here because nothing's moving in the x direction. And then afterwards, this is moving to the left. This is moving to the right. Yo, what's up, Obi? Shout out to Obi. Obi's another fun math streamer of our friends. One of our friends. Yeah, okay. So, and correct me if I'm wrong here, because maybe you have the solutions to this. But yeah, so I believe that 0.5 times 4, so that's the momentum of this thing, has to be equal to 3 times x. Have you seen this question before, Obi? And then obviously this is to the left. So 0.666 or whatever, or just 0.6 or here. No, it's just 2/3, right? So sorry. So this is 2 is equal to 3x. So x is equal to 2/3 meters per second, or that's called v2. And I'm gonna put that in the negative direction. Yeah, I think by conservation of momentum, because I don't think there are any horizontal forces. I'm pretty sure there aren't. Yeah, kinetic energy. Yes, okay, so actually there is something cool here. There's something very cool here. So now we're going to do conservation of energy. And so for those that are watching from my physics class, we haven't learned this yet. This is a new thing. Okay, but energy is definitely conserved because there's no non-conservative forces happening here. There's no friction. Yeah, no, you're right. So in this case, we have a bunch of different energies. So there's kinetic energy, which is equal to 1/2 mv squared. And then there's potential energy due to gravity, and that's equal to mgh. Okay. So because everything is at rest here at the beginning, we can say that the kinetic energy is equal to 0 for the beginning case. However, there is potential energy. And so potential energy is going to be equal to m1g times h, because it starts at a height h from the ground. All right. Afterwards, so this is conservation of energy. Energy. Afterwards, this block is moving. This whole ramp is moving, so there's definitely some kinetic energy. And so what will we say is that the kinetic energy of the ramp is 1/2 m2 v2 squared. v2 is negative, but squaring it just makes it a positive number. And then we also have the kinetic energy of the block. And now the potential energy is equal to 0 because the height that this block had that was giving us potential energy has now dropped down to 0. So this is 0. So by conservation of energy, the total energy here has to equal the total energy here. So m1gh is equal to 1/2, and then it's m2 v2 squared plus m1 v1 or m1 vf squared. And we have everything else, right? I can just move all this over. Cool. What is it? M1 is 0.5. M2 is equal to 3. V2 was equal to 4? Yeah. No. Sorry. V2 is equal to negative 2/3. VF was equal to 4. Yeah. Okay, cool. All right, so then you just solve. So 1/2 3 times 4/9 plus 0.5 times 16 all over 0.5 times 9.8. So this will cancel with this. 12/9 plus 8 over 9.8. 12/9 is the same thing as 4/3. So 1.33 plus 8 over 9.8. So I don't know. That's 9.3 over 9.8. I'm going to say it's about 1. Yeah. Around 1 meter. Is what we should have gotten. But yeah, that's a cool question. Thank you, Anton, for submitting it. Please let me know if that helped you out or if that's right. I always like to double check our work. Cool. Good job.
Well done! Well done!
Okay. 42 on YouTube. Damn, we are cranking today, bro. Welcome to YouTube. Cranks. Where's Equity? Equity, where you at, dog? Where's my boy Equity? Otherwise, I'm gonna go to Shantrix Funland. Question 21. No, this one shouldn't be so bad, Shantrix, right?
I'm gonna say crank means something very different here.
Crank is not a good thing to do.
You done messed up, Aaron!
Don't do it, kids. Shantrix is here. Okay, Shantrix. Yeah, let's try your question out, dude. Okay. Ooh, I like that there's gold marbles. I'm a big fan of the gold marbles that are here. Okay, box 1 contains 1 gold marble. Ooh, wait 1 second. I gotta do a CAPTCHA test for TikTok.
Box 1 contains 1 gold marble and a cesium atom.
That's the Jason Statham movie, right? Which one is the Jason Statham? Oh, Crank? It is Crank.
Crank
yeah. Is the movie. Oh, dude, that movie is great. It's ridiculous, but it's great.
I think there was 2 of them.
There was. I didn't watch the second one because I was satisfied by the first. The second was probably even more ridiculous. It's like the John Wick movies. Aren't we on like number 4 now? Yeah. Okay, so that's box 1. No, box 2. What's box 2 doing? What's in the motherfucking box? House. Okay. And it contains 1 gold and 2 blacks. What's in the box? Apparently gold marbles and black marbles. Okay, and then there's a third one. Okay. I don't know what I'm drawing. I'm just having fun drawing these pictures at this point. And that has 1 gold and 3 black. Good. 1 gold, 3 black. Whenever a marble is chosen randomly from one of the boxes, each marble in that box is equally likely. Cool, awesome. A marble is randomly chosen from box 1 and placed in box 2. Then a marble is randomly chosen from box 2 and placed in box 3. Finally, a marble is randomly chosen from box 3. What is the probability that the marble chosen from box 3 is gold? Oh, wow. Oh, you're talking about work function stuff? That's cool stuff. That's what is that called? The photoelectric? I think he's talking about the photoelectric effect. That's the photoelectric effect, I think, Max, is what you're talking about. We can get to that. Okay. Okay, so I think we have to, like... Do I want to draw out... Do I want to draw out a probability tree? I feel like I kind of want to. Photoelectric effect, correct. Yes, it is the photoelectric effect. Yeah. Ding, ding, ding. Okay. Okay. All right. Step 1. Take marble and put it into... And put it into box 2. And put it in the CZ atom.
Disqualified!
You would kill yourself.
Alive or dead? Alive or dead?
We don't know. Okay. Okay. Step 1. So there's a 50-50 shot on this, right? There's a probability of 1/2 here, and there's a probability of 1/2 that now box 2 has either 2 gold and 2 black, or it has 1 gold and 3 black.
Racist. Racist marbles.
Racist marbles. Okay. Okay. A marble is then chosen. Okay. The marble is randomly chosen from box 2 and placed in box 3. Ooh, okay. Okay, no, this is not bad. It's not bad. Okay. So now there's also a 50-50 chance here, right? Because you can either get a gold or a black, right? So this was us getting choosing a gold. This was us choosing a black. Now we could also choose a gold. And then box 3 would have 2 gold and 3 black. So this would be 2 gold, 3 black. I see. We're gonna have like an expectation value here. This is pretty cool. And then this is also a 1/2 chance. This is a 1/2 chance. And then this would have 1 gold and 4 black. Okay, cool. And then from here, now there's a 1 in 4 chance for a gold and a 3 in 4 chance for a black, because there's 3 blacks in the 4 marbles that are there, or whatever. Okay. I like probability trees, or what are these called? Yeah, probability trees, right? These are fun. Okay. So if you get the gold, now it's 2 gold, 3 black. I thought they're going to do something where like it goes back into like box 2. Then that becomes really difficult. And then this would be 1 gold, 4 black. Okay. Finally, a marble is randomly chosen for box 3. What is the probability that the marble chosen from box 3 is gold? Wow. Okay. So the probability it's gold from this one is 2 out of 5. And that's times all the probabilities to get there. From here, it's 1 out of 5. From here, it's 2 out of 5. And from here, it's 1 out of 5. But then, in order to get to this part of the tree, let me use a different color, sorry. In order to get to this part of the tree, we had to go from a 1/2 and a 1/2. So this is 1/2 times 1/2. To get to here, it was a 1/2 and a 1/2. So that's cool. From here, it was a 1/2 chance to do this, and then a 1/4 chance to do this. And then to go from here and then to go to here was a 1/2 chance, and then a 3/4 chance. And then all of these should add up to 1. Because there's a 100% chance something happens. Okay. So this is a 1/4 times 2/5, so that's 2/20. This is a 1/4 times 1/5, so that's 1/20. This is an 1/8 times 2/5, so that's 2/40, which is the same thing as 1/20. And then this is 3/8, so this is 3/40. Oh, so we have to keep things in terms of 40. Okay, so 3 over 40 plus 2 over 40 is 5 over 40. Plus 4 over 40 is 9 over 40. Plus 2 over 40 is equal. So if you add all these up, I think you get 11 over 40. Which was choice A. Is that correct? Was the answer choice A? Equity? Or not equity, sorry, Shantrix. Yeah, it is a probability tree, but yeah, you have to connect all the boxes to each other. Kind of fun.
Look at
what's up, Equity?
Wonderful people on YouTube not pressing the like button. What a shame.
Press the like button, otherwise Sensation's going to come after you. Equity, we'll do your question next if you want help. Oh, that is the answer? Nice, we got 11 over 40. Yes, yay, good job.
That's dope. Good job.
Nice.
I won't come after them, I'll just feel disappointed.
Well done.
Yeah, you don't want Sensation to be disappointed in you, dude. Don't you don't want Sensation to disappoint you. Alright, I don't see any web screenshots yet, so let's look at this one. Bro, what? These were their solutions? Dude, what? Denzel, thank you for the Shane gift card. It actually works. Bro, what? Get the fuck out of here.
Huh? What?
Someone on
Where?
YouTube, there's a YouTube scammer. Can you, you're a mod there, right? Can you go just like ban them or something?
Listen, scamming twats, kill yourself. I'm not going to be subtle about that, am I?
No, you can do whatever you want. Yeah, you can be. Yeah.
Report.
So this is the tree they did for it, which I don't know, kind of looks like some like satanic pagan like symbols. But
Surprise, motherfucker.
I feel like I liked mine a little bit better. Other Arion says, do you have book suggestions for linear algebra? If you already know, what do you think about linear algebra done right? Is that a book called Linear Algebra Done Right? Also here, Equity, stick around. I'm gonna do your question next. Let me just figure out this book. Because I do have
Anyway?
Shein is the cheap Chinese clothing company, fast fashion, whatever they call it.
Oh.
It's
Made
like
by slave
H&M.
labor. Don't buy it.
Yeah, it's like H&M, but like even cheaper. Yeah, I do have a textbook that I like for linear algebra. One sec, I have it somewhere. One sec, let me find it for you. It's in my Dropbox, which I don't necessarily want to pull my Dropbox up on the stream real quick because might be other things in my Dropbox.
Big titties.
Big horses.jpg or something. Where is it? I'll find it. Give me a second. Textbooks. Yes, here we go. This book came recommended to me. I don't know if you've seen it before. It's Elementary Linear Algebra by Anton and Rores. I do like this book. If you want a copy of it, just join my Discord and send me a DM. I'll give you the PDF. But yeah, I really like how it describes like things like this. Because linear algebra is very difficult sometimes to visualize. That's probably the hardest thing about linear algebra is visualizing it. And if you can think of, like the planes having different solutions, like where they intersect and stuff, this is like really cool. Yeah. Super cool. Linear algebra is great. If you ever want to get into any sort of like computer science, programming, doing whatever, AI, all of this stuff is linear algebra. So you should learn linear algebra. Is it rigorous and abstract or more about doing calculations? I feel like it's a healthy balance of both. Because it definitely shows you like procedurally, like for instance, this is how to do like Gauss-Jordan elimination. It'll show you the procedures, but then also it has like theoretically like, oh, if this is invertible, what does this mean or something. So yeah, so this is, you see how this is kind of like theoretical and stuff. So it'll take things to like more general forms. I think it's very cool. I'm a big fan of this book. It's, yeah, join my Discord and say hi to me if you want it. Good, nice dry nose. That's a really ugly integral, but okay. Yes, let me help out Equity real quick. And then, yeah, dry nose, I see your question. It's this one. This one might be really tough too, bro. What? It's in the exponent as well? Maybe this is an integration by parts. But here, I'm going to put this on another page. We'll get to it. Let me have Equity real quick. It says the graph of y equals 1 intersects the graph of y equals tangent of x at. Oh, okay. Well, Equity. This is just saying that, like, 1 is equal to tangent of x. Okay. So you just take the arctangent of both sides. You can also just think about, like, where is tangent of x equal to 1? And it's at the 45s, right? If you want to do it this way. This goes away. And then this is just going to get you pi over 4. Right. Technically, 3 pi over 4 also works. I believe. Wait, pi over 4. 2 pi over 4. No, 5 pi over 4, sorry. Let me give you your point, Shantrix. I almost forgot. One sec. Yeah, because tangent is opposite over adjacent, right? And so if you're looking at like the unit circle as we go around, you need the opposite to equal the adjacent. And that only happens here when this is 45 degrees because it's a 45, 45, 90. It technically also happens here, but this part is negative. So here tangent is -1. And then it also happens here because now this is negative and this is negative and negative or negative is positive. So yeah, that's not a very bad one. Let me see this one. Here, let me try this integral one. Yeah. Okay. Evaluate the integral. anytime I see... I gotta remember... What is I think the integral of a to the x dx, I believe, is ln... Is it a ln of a to the x? I don't remember. No, where'd it go? Ooh, Discord does work. The bot doesn't work on TikTok, unfortunately.
TikTok, no.
No, the Chinese don't let me have access to the APIs. Oh, cool. I see how someone's... Yeah, but I need to know... Oh, well, that's e to the x. Oh, so yeah, that would make sense that it's an ln trick. Top left. Where'd you see it? Oh, duh. Yeah, and actually, there is a cool proof to why this works. Other Eon. Yeah. So I was close. I think what you end up doing, yeah, is like you take the ln's of both sides, I think, is what you do. Yeah, there's a cool proof for why this is. I can go through it later, but okay. So, I would like to get this... Hello, can you please stop the get out of my stream and stop procrastinating? I need to finish 3 assignments. No, stay here, Disenfants.
My man.
We have cookies. Okay, so I would like for this just to be something to the x. That would be beautiful. However, that is not the case. Because I have this thing out front, which is messing everything up. And integration by parts, exactly, Alvaro, is what you want to do. Because if I can keep reducing this down till eventually this is gone, then we're great. If this was like a derivative of this, then I could do u sub, which would be great. But I don't. So, I gotta reduce it. Yeah, so here's what I'm gonna do. So, yeah, anytime you see something where, like, if the powers went down, things would get nicer, and you know how to integrate the other thing, do integration by parts. So, here I'm gonna say that u is equal to x. So then du is equal to just dx, because the derivative of x is just 1 dx. That was really nice. Okay, where things are going to get ugly is this part. So dv is going to equal to 6 to the 1/2 x plus 1. Okay. This is like, oh man, this is a u sub. This is a u sub. So we're gonna call it w sub. Okay, because I need to figure. And this is this dx. There's also a negative out front. I'm gonna leave the negative way out for the very end. We're just gonna leave it way out there. Okay. Okay. All right. So by this logic, if I want the integral of 6 to the 1/2 x plus 1 dx, I'm gonna say let w equal 1/2 x plus 1, then dw is equal to 1/2 dx. So dx is equal to 2 dw. So now this is the integral of 6 to the w times 2 dw. So this can come out. And integral of something to the w dw, this is now going to be equal to 6 to the w over the ln of 6. And then this is times 2. And then w is equal to 1/2 x plus 1. Okay, cool. So v is equal to 2 times 6 to the 1/2 x plus 1 all over the ln of 6. Okay. So now, it's going to be uv minus v du. So that's going to be 2x 6 to the 1/2 x plus 1 all over the ln of 6 minus the integral of v du. So now this is 2 over the ln of 6. I can take the constants out. Those are fine. And then it's 6 to the 1/2 x plus 1 dx. So yeah, whenever you do this, it's... I should have color-coded this. But it's uv minus integral of v du. Okay. And then I already know what this is. Yeah, we already computed what this bitch was. This is this. Nice. I love that. We don't have to do work again. Right, okay, cool. So then this whole thing is the same thing we did here. So this is going to be 2 times 6 to the 1/2 x plus 1 all over the ln of 6. And then we still have a minus 2 times over the ln of 6 minus... no, sorry, the minus is there already. I take that back. And then it was 2x 6 to the 1/2 x plus 1 over ln of 6. And then to make everything super spicy, at the very end, there was still a minus sign on the outside. So this is all minus. So, I don't know. This is just ugly. So, that's just 2x 6 to the 1/2 x plus 1 minus, right, ln of 6. So actually, I'm going to move this all the way over to the left. And then this is going to become, so minus minus is plus. So this is 4 ln of 6 squared times 6 to the 1/2 x plus 1. Which, I don't think it really simplifies very well. But yeah, I think that's it. Let's see if there's something simpler to this. So one sec. Let me take this. And I'm gonna ask ChatGPT to just do it. Actually, I'm gonna ask Wolfram to do it, but we're gonna have Wolfram like tag team with ChatGPT. Because I'm gonna go to ChatGPT. I'm gonna say, take this integral and give me a text form of it I could put in Wolfram Alpha. And I'm going to turn it down to ChatGPT 4.0 because we don't need to kill too many dolphins today. Cool. And then look at this. See, this is so nice. It just does it for me. I just copy this. Then I'm going to go Wolfram Alpha because Daddy Steven is like the alpha of math. And there we go. So that looks pretty similar to what we had. I'm sure there's like some slight constant here that I'm missing. So let's see. So they had 6 to the 1/2 x. Okay, cool. Oh, the plus 1 means you're going to multiply a 6 on each one. Now this is kind of cool. So 6 to the 1/2 x plus 1 is the same thing as 6 to the 1/2 x times 6 to the 1. So you get an extra 6 coming out. That's where the 24 comes from. Extra 6 come out. That's the minus 12x. And then it's ln of 6 squared, ln of 6. And then you have the 6 to the 1/2 x on the outside. Nice. Cool. So yeah, we got the same answer. I agree with it.
That's dope. Well done. Well
It's actually interesting. So there's actually a weird thing here in math. I had this issue when I was tutoring someone last night in chemistry. So when math writes out log of a number, they technically mean that it's log base e of that number. I don't know why they just don't fucking write ln. They don't. Right? My math people, my math homies here. Can you like speak to this? Like whenever Wolfram or whenever anything like formal in math talks about log, yeah, dude, this part. They say log of x is the natural logarithm. Dude, this part right here, this annoys me to no end. Dude, you know it takes less characters to write ln? Why don't you just write ln? Because when they want it, you learn in school that log of something is the same thing as log base 10 of something. But then if you get into higher level math, you now need to literally write log base 10 in order for it to mean log base 10. And so now ln is just superfluous with this. I don't know, it's kind of silly. Anyways, nice. Good question. Justin, what's up, dude? Everyone say hi to Justin.
Bro, what is log?
What is log? That's a good question.
Yeah.
What is log? Yeah, okay. So log is a function. Do you want to learn about logs? Log is pretty cool.
Actually, yeah, sure. Even though I'm in what development algebra?
Developmental algebra, bro. Aren't you in high school? What the fuck are you doing in developmental algebra?
9th grade. Yeah, I don't know. Don't ask me.
All right, you should know what logs are in 9th grade. Like, it's not that bad.
You're funny. My school curriculum sucks. Curriculum? Yeah, curriculum.
Aren't you in like?
Sucks.
Are you in Florida? I forget. Are you in Florida?
No, Ohio.
Oh, Ohio. Oh, that's Skibbity. Nice. Okay.
Okay. No.
Okay.
Oh no.
He's like, stop it, Dad. You're embarrassing us. Okay. So here's the cool thing. So if I say the log base a of b is equal to some number c, this is the same thing as saying a to the what, a to the c is equal to b. This is called log. I know. This is called log form. This is called exponential form. Logs are cool because they pull down exponents. Justin, is what they do.
Oh, okay.
Yeah. You'll learn that eventually. So here, I'll just give you like a little, I don't know, practice question real quick. Let's say we had the log base 2 of 8 is equal to something. What would that be?
4?
Close. Okay. So, right, you saw 2 to the something is equal to 8, right?
Yeah.
And you thought it was 4. And that's a common mistake. Everyone always thinks that, like, 2 to the 4th is 8, right? Unfortunately not. So, let's think about, like, what 2 to the 4th is, right? What does it mean when something is 2 to the 4th? Like, what are you doing?
2 times 2 times 2 times 2.
Good, let's do that. 2 times 2 times 2 times 2. Okay, what's 2 times 2 times 2 times 2?
4 times... Well, I already got the 4 down, so 2 times 2 is 4. 4
Good.
times 2 is 8. 8 times 2 is 16, so wouldn't it be 16?
Exactly. This would be equal to 16. Right? 2 to the 4th is 16. Right? Not 8.
Oh no.
Right? So, it turns out 2 to the 3rd is equal to 8. Do you see that? Right? 2 times 2 times 2. Yeah, good. Okay, so the log base 2 of 8 is the same thing as 3. There's a little trick.
Oh, okay.
Okay, now if you want to see something cool about this, right? So we said, right, log base 2 of 8 was equal to 3. I could rewrite 8 as what? 2 to like what exponent?
2 to x?
2 to an exponent, right? 2 to the what was equal to 8?
2 to the 3rd power.
Good. Yeah, 2 to the 3rd, right? Okay, so here's a cool thing. Whenever you're taking the logarithm and you have like the base here matches the number that it's hitting, the exponent comes down out front. Okay.
So then it would be.
So what does that mean?
Log.
Yeah. So what does that mean? Log base 2 of 2 has to be.
It'd have to be 4.
No. 3 times what equals 3?
3 times what? 3 times 1.
Yeah. So log base 2 of 2 is 1. You see how this this has to be 1?
Yeah.
And let's think about that. Watch this. Log base 2 of 2, right, is equal to something. Right? Remember the rule? It's like this to the this equals this.
So it's like a circle in a way.
It is a circle. Yeah, it's a big circle jerk is what it is. So, yeah. So 2 to the what is equal to 2. Duh, this shit is equal to 1. And so that's why the log base a of a is equal to 1. If these numbers match, this is always equal to 1. And the other cool thing you learn here is the log base a of b to the c. Like if there's an exponent here, this exponent always comes down.
Right, and then it multiplies into it.
And then it multiplies into it. And so if these are the same, right? Then this goes away and this is 1. Yeah. and so she's equal to C. Yeah, so it's all self-consistent. It's cool. Like math is like a big like puzzle. It is like a spaghetti. It's pretty cool. Is that dope?
Yeah.
Does that make some sense? It makes some more sense to you, Justin?
Yeah, it does make a little sense. Do
Hell
I
yeah,
get a
dude.
bond coin for that?
I'll give you one. Yeah, dude. Yeah, you you get a coin for that. Nice. I need to power on my fucking my Oculus, dude. You said
Dude,
you got
Oculus is on its like final breath. I swear.
What's wrong with it?
Poor thing will die within an hour. It doesn't even
Oh,
stay
no.
on for the extra hours I used to have it.
Oh, that means the battery's shot on it. You just need to run an external on it.
Oh yeah, no,
Right.
I'm getting a battery pack soon. So.
Or you could get the new Oculus. Looks dope. I tried it out at this conference I was at. Yeah.
I ain't got $300.
How much is it? Is it $300 now? The new Oculus?
Yeah. The
Wait, isn't
3S's.
Isn't there like
Quest-
a Pro one that's like $500 or $600?
No, the Quest 3 is the $500 one. The Quest 3S is the $300.
Oh, okay. Do people still play Population 1?
I have no clue. I haven't played that game in a while.
You just play Gorilla
I've
Tag?
been playing. Nah, I've actually been playing like VR chat with one of my friends, just going around the most random worlds.
Oh, okay. That to me is fascinating that like kids your age can basically interact with like, I mean, we had it too growing up. We had chat rooms and shit, and there was a bunch of sketchy stuff there for sure.
Microsoft, Skype.
Yeah, but I've you know, ICQ, Sensation probably knows some of even the older ones, but
Yeah.
Yeah.
Second Life.
Second Life, yeah, that was one. Yeah, but yeah, so you guys have VR chat, which is kind of like Second Life, I guess, but it's more immersive for them, right? Yeah.
Yeah. We also have like Rec Room and stuff. So we got Rec Room, Gorilla Tag, all those games you can go to a custom world in. Like Gorilla Tag recently added custom worlds you can go into.
Oh, okay. Are people still doing stuff where they making like, I don't know, Roblox started getting like highly racist at some points. Like they would have like cotton field simulators and stuff. I was like, God damn it.
Every game I would walk into with voice chat, you're gonna hear the N-word being spammed. That's all I can say.
That's so dumb. Reminds me of the Xbox Live days.
Nice.
MW2 2009 voice
There you
chats.
go. Yeah, there you go. The voice chats, glory days. All right, nice. Well, good to hear from Justin. I gotta let me help this kid with this whatever question. But we should play sometime. Go get the finals. Nice. Okay. Evaluate the integral 3 to infinity of -4 over x ln of x to the 6 dx. Okay, this is cake. I think it's cake. I could be wrong. Oh, I think I need the ln of x on the top. Well, okay. Because what I'm tempted to say is that u is equal to the ln of x. So then du is equal to 1 over x dx. So that means dx is equal to x du. Right? So my integral here is now -4 over x u to the 6th. Oh, it is. And then this is x du. Wow. It is. Yeah, look at that. That's fucking beautiful.
That's dope.
Yeah. So this cancels. Bye-bye. Okay, cool. So, hell yeah, dude. So now we're just left with the integral of -4 du over u to the 6th, which is the same thing as -4 u to the -6 du. I'm not going to change my bounds yet. I will at the end. So this is going to end up being -4 u to the -7th over -7 evaluated somewhere. So one sec. Some things are going to cancel here. So I'm going to get 4 over 7, and then I'm going to replace my u back, which was ln of x. So that's going to be ln of x to the -7th, and then that's evaluated from 3 to infinity. Okay. So that's 4/7, and then that's 1 over the ln of infinity to the 7th minus 1 over the ln of 3 to the 7th, and 1 over infinity is 0. So we're just left with 4/7 ln of 3 all to the 7th. And I think that's it. It's not cake. It's wait. What is that? What is that? What is that? It's what does that thing say? It's trivial. Wow, it is trivial. Well, okay. This does look ugly, but there is. It's written out. The only reason I know how to do this is because I've been doing this for like 15 years, so I know which one it is. But anytime you see stuff that's like kind of weird like this, try separating out the fractions. So you can say this is the same thing as -4 times, I would say 1 over x times 1 over the ln of x to the 6th, okay? And anytime you see something going to like really high exponents, pretend that thing is just u. And then what you want to see is, does the derivative of your u thing show up again? And yeah, the derivative of ln of x, which is 1 over x, does show up. So it's going to cancel. Do you think anyone has ever needed to calculate ln of x to the -7th for any practical reason? I don't think so. I don't know. I really don't. Probably not. Can't say it's been helpful. Yes, when dynamics behaves like ln of x. He says yes when the dynamics behave like that. I mean, maybe. Dry nose, I appreciate these integrals. They're fun. Integration is like going to the gym for me. Actually, wait. I might have to actually teach another student. My bad. I lose track of time. I'm having so much fun with you guys. Oh, I do need to go soon. Fuck. All right. Let's see. Where's Equity? Equity, you did ask questions, Equity. Equity, my boy. He asked a question, then he dips. I didn't even come back.
Gold. Tell them they're being mean. They're not pressing that like button.
Oh yeah, you have to press the mic. Yeah. Press the like button. Press the subscribe button. Otherwise, Sensation will get upset, and he'll be disappointed in you. And you don't want Sensation to be disappointed in you. Look at this man.
So disappointed.
Can't have him disappointed. He's so disappointed. Don't be disappointed. Can you share students? I'm sure someone in your chat is in need of some cash too. Yeah, the issue is this student is like in person, so you'd have to live in Los Angeles. I teach a lot of students online for sure, yeah. But yeah, some of them are in person, and because they need like in-person help. Because if I taught them online, they would just be not focused. Depends on the students.
Anyway, where are we at?
I think I will do here. Oh, we have another screenshot. We got another screenshot question, and then I will do. I will do this one tangent question, which is weird. What's up, trying the boss? What's crack-a-lackin', boss? He's up in the his. I haven't seen you in the. Well, did I see you on Wednesday? I forgot. Dry nose is just.
Popping?
What's popping?
Corn.
My lip gloss is popping. This is rad as hell. Never thought there'd be a channel with just a bunch of people hanging out and doing math and other problems. Yeah, it can happen.
Well, that happens. I just give abuse though. So.
Sensation just gives the beatings. But yeah, for those that found us on TikTok, we're actually a actual nonprofit. So we help students out with math and science questions, and students of all ages. I don't care how old you are. You can be, we have some people that are like in 5th grade, which I guess are evading the TOS, but and then we have some people in their 60s or 70s that come on by and ask questions. It doesn't matter. Learning happens at all ages and all levels.
It's true. I'm going gray.
I'm going bald, dude. I'm look at my hair. I'm losing my hair, dude. I'm losing my hair.
Oh dear.
I've hit 35.
You're gonna have to shave your head.
Yeah, I'm waiting for it. Wow, 22 years, man. Don't feel too bad. Why?
Oh, because a friend of mine was like 19 and he just lost all of his hair.
Oh, dude, that's gotta be the worst.
His hairline was past his ears. If you go from the top.
He was just. It was like way back.
Yeah, like full on where my headband is.
The nice thing is he probably never got carded trying to get a drink.
I don't think he ever tried, to be honest with you.
Yeah, well, yeah. Probably no point. Okay, find the interval of convergence of the series. Oh, what's up, Equity? Equity, we'll do your question. Stick around, Equity. I want to help you out because I want to do. Where's your question? I want to do this one. I want to do this one for you. This is a really good one. Actually, do you want me to do it right now? Just because I got you and you're here? And then dry nose, I swear I'll come back and do yours.
It's funny how the boss says 22 viewers. We had 45 before.
Yeah, it's been going up. It's been cool. Yeah, I guess the algorithm is liking me. I did also post a bunch of like shorts on YouTube. What is it? If I go to my studio or something, where's my studio? Yeah, the more of these like short things I post, the happier they get with me. But yeah, so we do like tutorial videos too on like common math and science stuff. Like here's like how to factor really big polynomials, you know.
So here we have a plus
cute little video.
and we're asked to write
Maybe
out
you guys
that.
found us originally on
If the
YouTube from
biggest
this.
exponent was
But anyways, that's kind of like the bread and butter of like where I started with helping people out. And we also do live streams. Equity. Where are you, Equity? You here?
Equity.
Equity, you have to give us a pulse. Okay, whatever. I'm just gonna do it for him. All right. Okay. This looks strange. All right. So what I'm going to do is I'm gonna move this over. Wait, is this also? These are both tangent squared x's. What the hell? Yeah. Oh, yeah. Whatever. Okay. Maybe this is easy actually. One sec. My pen is way too fat. Okay, there we go. Okay, so is this just 1 is equal to tangent squared x? God damn it. Okay, cool. So that just tells me that tangent of x can equal plus or minus 1. And so on the interval from negative... the interval is actually kind of interesting here. From negative pi to pi. Negative pi to 2 pi. Game Repeated says, you have such a positive mindset and attitude. That's super cool to see. There's a ton of people out there teaching out of place, a passion. Awesome. Yeah, thanks, man. Yeah, I appreciate that. Yeah, I like to teach. Teaching's fun. It's, I don't know, it's pretty rewarding. It's fulfilling. I don't like the admin. I recently took a job at UCLA. I'm teaching physics there. And I absolutely love the teaching aspect. I just hate all the emails. Or the, I don't know, just like... I don't like the actual administration has been fine to me, but it's the act of being an admin. I don't like, you know. Okay. Negative pi is from here. And then we're going from negative pi to 2 pi. Oh, I see. So we're coming from here, and then we're going all the way around, and then we're doing it again. Oh, okay, cool. So because this is tangent of x is plus or minus 1, that means all like 45-degree things are good. So this one will work, this one will work, this one will work, this one will work. This one will work again. And then this one will work again. Okay. So you will have what is that? Negative 3 pi over 4. And then negative pi over 4. Pi over 4. 3 pi over 4. 5 pi over 4. And then 7 pi over 4. Yeah. Is there a pattern for this? Yeah, this is negative 3 pi. This is negative 3. And then I could say this is like 2n plus 1 pi over 4 for n is equal to 0 to or actually that doesn't work. Never mind. I take that back because that's gonna be odd multiples of it. Whatever. Just do this. It's okay. Yeah, I think that's all your teacher wants. All right, let's see this one. Find the interval of convergence of the series. The answer is a single value. Write that number only. Okay. So this is an infinite series. And first of all, for infinite series, there are a bunch of different ways you can prove convergence. So, infinite series convergence. If you want to know, like, the resident expert on infinite series, his name is Zach. I'll shout them out here in e to the 2I pi. Can I shout them out? Does that work? Nice, yeah. E to the 2I pi. He like wrote his PhD or his master's thesis on how to specifically teach infinite series and convergence, because it is one of the hardest things, especially in calculus. It's the thing that it's what separates AB calculus and BC calculus is sequences and series. So the whole thing is just basically it. Okay. So these are all the different tests you can do to prove for convergence. And what I like to do is anytime I see factorials, so factorials to me instantly tell me ratio test. I love the ratio test. Ratio test is great. Okay, so here's what we're going to do. So I'm going to take the limit as n goes to infinity of the n plus 1 term of this sequence divided by the n of the sequence. And it's also the absolute value of it. So what I end up writing is this as n plus 1. So that's going to be 4x minus 5 to the 2 n plus 1. And then this is 4 times n plus 1 plus 4 factorial all over n plus 1 factorial. And then we're dividing it by the regular one. So if you're dividing a fraction, you just multiply by the flip, change flip. So I'm just going to take this and flip it. So now I have n factorial over 4x minus 5 to the 2n. And then 4n plus 4 factorial. Okay, cool. So there's a lot of really cool things with, and this is why I like the ratio test with factorials, is because n plus 1 factorial is the same thing as n plus 1 times n factorial. So maybe for those who haven't really seen factorials yet, let me show you real quick how that works. So for instance, 5 factorial is the same thing as 5 times 4 times 3 times 2 times 1. So it's the same thing as we say 5 times 5 minus 1 times 5 minus 2 times 5 minus 3, and so forth until you get to 5 minus 5. Turns out that 0 factorial is just equal to 1. So if I have n factorial, that's the same thing as n times n minus 1 times n minus 2, so forth, which is the same thing as n times n minus 1 factorial. So now let's replace this n with, I don't know, like u plus 1. Let's just say like this whole thing is now u plus 1. Now I get that u plus 1 factorial is equal to u plus 1. And then this is now u plus 1 minus 1 factorial. So then this goes away. And so that's where I get my conclusion I said earlier, that n plus 1 factorial is just equal to n plus 1 times the next step down, which is n factorial. So, so this thing right here, we can rewrite as n plus 1 times n factorial. And the cool thing is now the n factorials cancel. Okay. So this is going to go away. This is going to go away. Even cooler. Okay. Let's try to expand this out a little bit. So 4x to the 2 times n plus 1 is the same thing as 4x to the 2n plus 2. So what I did is like, I did 2, wait, let me make sure I did that right. Yeah, 2n plus 1. So 2n plus 1 is the same thing as wrapping the 2, whatever. expanding, distributing. And so that's where we get that. And so now here's the cool thing. This and this are the same. They just have different exponents. And remember, if I have like x to the a over x to the b, this is the same thing as x to the a minus b. So this is going to be 4x minus 5 to the 2n plus 2 minus 2n. So here, 4x minus 5 to the 2n plus 2 over 4x minus 5 to the 2n is the same thing as 4x minus 5 to the 2n plus 2 minus 2n, because you can subtract the exponents. So this goes away, and you're just left with 4x minus 5 to the 2. Okay? So, cool. This chills up here. This goes away. This is always a pain. I always remember this being a pain. This is where I like start losing my marbles. Okay. So now let's look at this thing. So this is the same thing as 4n plus 4 plus 4 factorial over 4n plus 4 factorial. Oh, very cool. So this is 4n plus 8. Okay, this is the same thing as 4n plus 8, 4n plus 7, 4n plus 6, 4n plus 5. Notice how like each term is just dropping 1, right? Times 4n plus 4, and I'm going to stop here, factorial. So this part is factorial, and then these are like the terms like I kind of expanded. And so then this is all over 4n plus 4 to the factorial. So then these are going to cancel as well. So then this goes away, and I'm left with this huge fucking mess. God damn it. Oh, that's so gross. Okay.
What the fuck is this piece of shit?
Anyways, cool. So now this is going to go... Can I explain momentum? What's up, Melly? I can. Do you have a question about momentum? So, we did momentum earlier. I was doing... This was a big momentum question we did. But if you have a screenshot of a question, Melly, that's the best way for me to help you. That's what people are doing. So, Melly, people, like, send us screenshots of homework questions they have. And I go through it and like teach it along the way. There's a website down there on the... You should see the link there. It should work out pretty well. Okay. Okay, but now this is gone too, right? We got rid of this as well. Okay. Cool. So wait, we want to know when does this converge? I think when x equals fucking 4/5 or something. Because, yeah, look what happens here. So this is an absolute monster. Right? This is an absolute monster. And then this is 4x minus 5 squared. And then it's all over n plus 1. And then what we say for the ratio test is that if it's equal to L and L is less than 1, then it's convergent. I don't... Oh, can I have it equal to 0? Yeah, I think I can have it equal to 0. So here's the issue here, right? So, and this is the limit as, I think, n goes to infinity, right? Yeah, it's... The ratio test is the limit as n goes to infinity. So this is going to be something on the top that's of order n to the 1, 2, 3, 4, order n to the 4th. And this is going to be of order n to the 1st. So this will almost always diverge if n is going to infinity. The only way for this to converge is if this term here, like, explicitly equals 0. So I think the only way this converges for x, so for basically 4x minus 5 equals 0, or x is equal to 5/4. I think that's the only way it converges. Yes, Equity, I can do yours. Well, yeah, which one do you need help with? I did this one. Did you see this one, Equity? Dun, dun, dun. And here, I want to see what ChatGPT says on this one. Let's throw it on the high one. We're gonna kill dolphins. Okay, solve this. Yeah, not a super interesting theory if all the terms are 0. I agree. Well, are the terms all equal to 0? Oh, they are actually. Yeah, that's like really. Well, it says the answer is a single value. I guess we could have just looked at this and said the answer is it's just wherever that equals 0. 04 is better than 01 for math, I believe. Okay, you want to start with the word problems? Yeah, I can do that. Yeah, so they did a even ChatGPT, I think, did an announcement on, like, because believe me, it is confusing to know what all the different models are. Let's see if this got it. Yeah, see, there you go. Only converges for 5/4. Duh. Yeah, one sec. They did something here. It was ChatGPT. Announcement, different models. I think the big thing is actually that they actually kind of all work with each other now. And depending on what your problem is, it'll self-select which one it needs to do. So here we go. So O4 is faster and more affordable. Well, okay, so O3 is the most powerful. I feel like yeah, O3 is the most powerful. O1 solved a nasty stochastic integral for my thesis. Don't tell my advisor. Yeah, there's one where it's just math. Text and prompting. Maybe it's reasoning. Yeah. So I think O3 is like kind of the big one to use right now. O4 for me is like cool with coding, and also just using 4O is great, honestly. But this one worked out. Okay, cool. Here, let's do this one for you, Equity. And then Melly, if you're still around, I can explain some momentum to you if you want. Anecdotally, I haven't liked O3 for math. Yeah, I guess it depends on the math you're doing. Especially, you guys do like some really high-level math sometimes that, to me, stops becoming numbers. Okay, a buoy bops up and down in a lake. The distance between the highest and lowest point is 1.5. It takes 6 seconds for the buoy to move from the highest point to its lowest point. Okay. And then what's the question? What was the question, Equity, on it? Do they just want an equation for it? Dun, 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 dun. Okay. Oh, what's happening with that thing? Okay. All right. I'm gonna assume this is periodic motion. So let's assume it does this. And the distance between its highest points and its lowest points is 1.5. Okay. So going from here all the way down to here. Or let me use a different color, sorry. This is equal to 1.5. So that means this is half of that, and that's going to be 0.75. And then they say it takes 6 seconds to go from here, from the highest point to the lowest point. Okay. So that's cool. So this distance of 6 seconds, this is half a wavelength. So 6 seconds for 1/2 a wavelength, or we could say like 1/2 of a period, I think is really what you want to say. So that means that a full period, so the full amount of time it would take for it to do a whole cycle, is equal to 12 seconds. Okay. So then when writing out your equation here, this is y is equal to a, the amplitude, which in this case is 0.75. And then I had this one start at 0, so I'm going to say sine. Doesn't really matter, sine or cosine. It's just a phase shift. And then I think it's like omega t plus phi, where omega is equal to 2 pi over the period. So I believe this is going to be 0.75 sine, and then it's going to be 2 pi over 12, so that's going to be pi over 6 t. And then just assume the phase shift is 0. I think that's it. Oh, sorry. You're so right. I didn't read the rest of the sentence here. 6 seconds for the highest to the lowest, and then back to its highest. Oh, sorry. Yeah, you're right. You're right. That's kind of mean that they put this on the so it's pi over 3. Yeah, pi over 3. So it's 6 seconds for a full period. Yeah, that's not too bad, right? Okay, and let's see this one. It says the octopus ride at an amusement park completes 1 revolution every 60 seconds. Cool. So period is equal to 60 seconds. Amplitude is going to be equal to it's always like max minus min over 2. So 4 minus 1 over 2 is 3/2. The offset, like I say, like the plus c, is always max plus min over 2. This is called like the midline. And so that's going to be equal to 5/2. Okay, cool. So there you go. So h is equal to 3/2 sine. They use kt. So it's kind of cool. K is equal to 2 pi over lambda, at least in physics, right? K is like a wave space number. But it's also, right, over period. If we do this, you should use omega. So that's going to be 2 pi over 60, so that's going to be pi over 30. And then that's going to be t. And then plus c, there's 5/2. Oh, wow, someone's making me drink water. Thanks, Sam. What's up, Sam? Sorry, I had to refill my water bottle up here. It's getting kind of warm in here. We're at 78.9 degrees now. Translation was 5/2. The period of the function, 60 seconds, and the value of k is going to be pi over 30. I have a video on this, if you ever want. It's on my YouTube somewhere. You got another test, Sam? Do you got a question? You want me to help you out? Dude, what's Fresh and Fit doing with credit cards? Dude, what? Excuse me, Fresh and Fit? Dude, what? I don't think I would trust credit card advice from those people. Yeah, I have one on here for like graphing sinusoidals. No. Fuck. 1 sec. Sinusoidal? I could have... Okay, here we go. How to graph sinusoidals. Yeah, go watch this video at some point. Equity. This is a really good one.
You'll be given some sort of sine or cosine.
And this shows how to graph it. You're all good, Sam? Nice. Okay. Nice. Let me see.
My turn.
What's your turn? What's up, Sensation? What's your question?
I've got a 3-step question. It starts off real easy.
All right, what's the real
Okay,
easy?
so you've got one of those tumbler locks with 4 numbers on it.
Okay. Yeah, like a code, like a padlock.
So we know the total combinations are 10,000.
Yes.
Okay, so how do you work that out mathematically?
Oh, I like that. That's a good one. Yeah, good. Okay. So this is like combinatorics, I guess is what it is. So you have 4 registers, right? And each one of these registers could be like 1, 2, 3, 4, 5, 6, 7, 8, 9. And is there usually a 0 on there? Right?
Yeah.
Okay, cool. So the math way to do this is that right, 10 to the 4. So you do, it's like the number of combinations here times the number of combinations here times the number of combinations here times the number of combinations here in a row. So it's 10 times 10 times 10 times 10, which is 10 to the 4th, which is the same thing as 1 with 3 zeros behind it. Or 4 zeros behind it, sorry, 10,000.
Yeah.
Yeah.
Okay, so that was step 1. That was quite easy.
Step 1 was easy. Okay, cool.
Step
Step
2. You have a 4-letter password. For the sake of simplicity, we'll say it's all lowercase. A through Z, 0 through 9.
Okay.
Total
4-letter password. Good. Okay. So same concept, except the number of combinations now is no longer 10. It's is it 36? How many letters in the alphabet? Is that 26?
26.
Okay.
Yeah, so 36 total.
So 26 plus 30 plus 10, right, from 0 to 9. So that's 36. But now it's 36 to the 4th, which that's a very big number. 36 to the 4th instantly becomes, yeah. Here, I'll pull it up. It's very big. No, not that. Yeah, you're already looking at 1,679,616.
Without getting too deep, that's why you have long passwords. Because I mean,
so this isn't this isn't even just like long passwords. This is just once you add the number of combinations that are. This is why alphanumeric is important. Okay. Because let's say, okay, let's say fuck the numbers. Okay, let's just say we're just doing alpha, right? 26 to the 4th, okay? Once you add case sensitivity to it, now it's 52 to the 4th. Okay? And so you can kind of see like what happens. So instead of being just 26 times 26 times 26 times 26, it's now 26 times 2. 26 times 2, 26 times 2, 26 times 2, okay? Which looks like the same 26 times 26, but except now there's a times 2 times 2 times 2 times 2. So that's 2 to the 4th, which is 16. So 2 times 2 is 4, times 2 is 8, times the 16. So doubling the number of combinations leads to a times 16 factor in the number of total combinations for your password. If you go from not case sensitive to case sensitive, if it's a 4-character password, it becomes even more extreme if your password is more than 4 letters.
Yeah.
Yeah.
So the powers is the placeholder.
Yes, the powers is like how many individuals. How many different. I'm trying to think, like slots. Yeah, that's what the powers are. Yeah, because once something is like over 16 characters, it's ridiculous. Because anything to like to the 16th power is, huge. Especially if and especially if it's alphanumeric, and then if you start putting the symbols in as well. So in reality, passwords look really difficult to crack like that, brute force wise, if you went through every single combination. But most people, when they choose their passwords, just literally choose like the name of their dog or something. So This is why dictionary attacks are like really, really effective.
Mhm.
Yeah.
Which brings us to step 3.
Step 3. What's step 3 here? What's my password?
So
Ask me for my password.
The government advice is to use 3 words
They want you to use 3 words. Interesting.
as a password.
Okay.
So yeah, assuming 200,000 words in the English language,
Yeah.
what's the total possible number of combinations given 3 words?
So it'd be 200,000 to the third.
Okay.
Because it's 200,000, 200,000, 200,000.
Yeah.
Which, what is that? So that's 2 times 10 to the 5th to the third. So that's 8 times 10 to the 15th. It's not that much. Yeah, that's not really good. That's not a good idea.
No.
Well, because, and again, that's how a dictionary attack would work. Is a dictionary attack would be like, oh, well, I know that the things have to be words, so I'm going to restrict myself to only those 200,000 combinations. Yeah, so this is kind of what we're getting at is if for instance you have like word 1, word 2, right, and word 3, and 200,000 is 2 times 10 to the 5th. Then this is just going to be 8 times 10 to the 15 total combination of like word, okay? So if the government tells you to do word, but most hackers aren't assuming it's word, like they're going individual characters, okay? Then this does get insane because let's say what's the length of an average word? Let's say length of average word in English.
6 letters.
Says 5.
5.
Okay. So 5, right? So that would be like 5 things here, 5 things here, 5 things here, which let's assume that it's just that words, right, don't have numbers in them. So it's just case sensitive alpha, right? So that would be 52. So right here, this would be 52 to the 5th times 52 to the 5th times 52 to the 5th, which is about the same actually. Right? Am I crazy? 52. I mean, this is a cool like question sensation. So it's it's definitely 52 to the 5th to the 3rd. No, okay, so this ends up being 5.5 times 10 to the 25. So that's much bigger than this. So that's 10 orders of magnitude bigger. Yeah. So the government telling you to say word makes it easier for you to remember, right? You could be like fox, lamb, whatever. But if hackers don't know it's word, and they're having to go, oh, I have to solve a 15-character password, it's incredibly difficult for them. Unless we use quantum computers.
Huh. I think we worked it out that even under the 3-word system, if a foreign agent took an interest in you, that still wouldn't take that long.
Yeah, and again, if a foreign agent really wants to get your password, he's not doing this. He's not brute forcing. There's things called like rainbow hash, NTLM tables. I used to do a bunch of this hacking stuff in high school. It was cool. What's up, Ethan?
Doing good.
Nice, dude.
I'm back to school again on Easter.
Okay,
Almost
nice.
done.
How's school going, dude?
It's all right.
Okay.
My grades are actually a lot better now.
Nice, dude. That's dope.
Yeah, I got like
Gotta reload this.
95s in almost everything now.
Oh, good, dude. That's awesome, man.
I can show you them. if you want.
Yeah, send me your grades. I gotta probably end the stream pretty soon here, but yeah, send them to me. Because I do have to go
Yeah.
teach another student.
And like how much more time do you have left?
I got like probably 5 minutes. Equity for this one. If it starts at the top, equity, and it's on its way down, that's a cosine function. So cosine starts at the top and ends down, which is kind of what I drew here. but sine starts at the bottom and goes up. So this one would end up being 0.75 cosine of pi over 3 times t. Yeah. What's up, Ethan? What's up? You have grades? You have grades to show us or what?
Yeah, but like, do you want the grades and DMs or?
Yeah, just send me your DMs. Yeah, I'll pull them up on the screen. I'll show everyone on the stream. We have a lot of people on the stream today. We got 25 in YouTube.
You know, the crazy thing is it's still not done. There's still more to go.
Yeah, life goes on forever. Yeah, look at this, dude. Sensation. You want to see this, bro? Look at this, bro. 2,862 views.
Wow.
Look at that. Wow. The funny thing is, like, the average duration is 30 seconds.
Yeah.
People only watch for 30 seconds. But I'll take the views. The views are cool.
See, I have the thing. I have it in the.
All right, nice. Let me check it out. Ethan's
what could you possibly learn in 30 seconds?
I don't know. They could learn that they need to like pay more attention.
Surprise, motherfucker.
Okay. Anyways, Ethan is a student that has been with us in the server for a very long time, and he's from Belize. And look at that, Ethan. Nice, dude. You got a 96 in CS. You got a 95 in bio, 93 in information systems, 93 in physics. Ooh, I like that.
Oh,
nice.
That will go up. That physics will go up.
Oh, good. Nice, dude.
Nice.
Because
we just
you
just need a little bit more in literary to get up to an A, and then I don't know what upper English is.
Upper English. That I'll have to stay there. There's really nothing else I can do.
That's okay.
Hey, let me tell you this. For physics, there's a sports day that's coming up.
Okay.
If I can just participate in the events, I get extra credit, and then I can go onto the physics. And the thing is that even just by participating, I get like 2 points every time.
Oh yeah.
It's just that I have a marathon tomorrow, and I'm honestly kind of scared. And the thing is that if I can come in the top 3, I'll earn more points.
Nice.
I don't know if that's possible. I don't know if it's possible though.
Anything's possible, dude. You just gotta keep trying.
Well, how do you suggest I run faster, or at least keep up a good stamina?
Run faster? What do you mean run faster? Like physically run faster?
Or just have a longer stamina. I don't want it to do.
Oh, protein's good. Yeah, protein's great. Eating carbs right before running. If you're talking about like mental stamina, taking naps. I love naps. I absolutely love naps. I'm a nap fiend.
All right then.
Yeah, take naps. Let your brain like chill out every once in a while. That stuff's pretty good. Okay. Cool. All right. I think that's all the questions for today. Also, I gotta go teach. So, dry nose. I love all these questions. Come by our stream. Yeah. So yeah, anyone who's watching us here, yeah, like, subscribe, all that fun stuff. But also, we have a calendar. If you go to just calendar.actual.education, and this is a live stream schedule of like when we stream, as well as some other friends. So we have E2I Pi. His name is Zach. He's a great, awesome math streamer, and he's going to be streaming. It looks like Tuesday, Wednesday, Thursday, around 8:45 Pacific. So for East Coast people, that's going to be like almost noon. So you could. He's going to do math education, and then 16 is his like video game he's developing. So this is really cool. So if you click on this, and also I shouted him out here. So yeah, make sure to go follow him. We have a bunch of other really fun math streamer friends that are right there. Go check them out. But yeah, so we went a little bit overtime today, which I was cool with. We had a lot of people in the stream. I was fine streaming a little bit longer. But our next stream will be tomorrow, starting at 4 p.m. Pacific, 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. Probably like 1 a.m. GMT. Is that right, Sensation?
Midnight.
Yeah.
Zero hour.
0 hour. Okay, cool. All right, let's close the stream off. Thank you everyone for coming to office hours. I love fun with you guys today. Appreciate all the questions. Appreciate all the learning. Super cool.
Everyone.
Tell all your friends. We're here to help. If you found me for my UCLA class, congrats. You can get
Buy me
free
whiskey.
help here. Buy me whiskey. I think I can say whatever I want here. I know I'm kind of limited in what I can say in class, but anyways, let's see. Who do we want to go raid? I Oh, that's fun. One of my friends is making music live. Okay, so here, y'all tell me, chat, where you want to go. So here, I'll give you some options. If you're on YouTube, this doesn't apply to you, but we can go watch my friend Julien make EDM music with this guy named Abstract. We can watch High Potential take notes. We can watch Physics Buzz. What is he doing? Looks like he's doing some coding. He's a pretty cool guy. We can talk to him as well. Or that's kind of, well, no, this is all the fucking thirst trap stuff on that. Yeah, or I don't know. Or physics and depression. Ooh, or we can do more college physics. I'm kind of tempted to do more college physics. Do you guys want to learn? You want to learn more physics? You want to learn about music, or you want to learn about like cool like coding? Someone say something in the chat. Cast your votes in the chat, please, and I'll send it. Also, yes, if you're finding us from YouTube, TikTok, make sure to follow. You'll get notifications when we go live, which will be tomorrow. Physics and depression. The people have spoken. All right, let's go say hi to physics and depression. I want to tell him that he's physics and like not so depressed anymore, because he figured out how to get rid of his depression. Love it. Okay, cool. All right. Enjoy the rest of your Monday, start of the week. We will see you guys tomorrow. Peace out.
Bye bye.
Bye bye.
It probably depends on the
okay.
the
All right,
type
let me
of
stop
grid.
that.